Now in today's lecture, I'm going to cover summation of series from sequence and series chapter. In this lecture, I'm going to cover all the types from summation of series from this chapter, type 1 to type 7, which is already been asked in IIT-JEE, or in future they can ask you. So from type 1 to type 4, they are pretty common series which we use every time. Now type 5 to type 7 are miscellaneous type, they can come in IIT-JEE in future IIT-JEE. So let's start with the type 1. Now type 1 is pretty standard and those who are preparing for competitive exams should remember at all times. That is, summation of n is n into n plus 1 divided by 2. Similarly, summation of n square and n cube here. Now the question arises why I am discussing type 1, because already you know this. So it does not mean this is not important. This is very important. We can make a good generalization out of it and that will be really fruitful result. So general idea here is important, which I usually give in this 3. That is, if you don't observe, you'll miss this idea and that will cost you one question in the exam. That is, if suppose one question is there in exam, let's say like this, summation of n into n plus 1 into n plus 2 into n plus 4. Suppose this is given in IIT-JEE mains, and you can select one of the option directly from the options. Okay, like mains like exam, you can select one option directly. The general idea I'm going to share right now, that is, if summation of n is given, then on the other side it will be n square by 2. One of the terms you will see that is will be n square divided by 2 for sure. Similarly, if summation of n square is there, on the other side you will see n raised to power 2, you will see n cube divided by 3 for sure. Because if you check here, you will get n into n, n square, and then 2n cube divided by 6 will be n cube divided by 3. Similarly, if you see summation of n raised to power 3 here, then for sure you will get one of the term that will be n raised to power 4 by 4. Similarly, for this question, as I was saying, if this question was there in any competitive exam, maybe it's a possibility that you can select one of the option if it is possible only. So the first thing you should look is, here we have n raised to power 4. Then on the other side, it should be n raised to power 5 divided by 5. So this idea will be really useful here in exams. Okay, if it is possible, I'm not saying every time it's not possible, but if it is possible, you can apply this. So let's move on to type 2. Now type 2 is method of difference, and I'll tell you why it is called method of difference also. Suppose a sequence is given like t1, t2, t3 and so on t of n, and this is the terms of a sequence. If the difference of the next term to the previous term, let's say t2 minus t1 or t3 minus t2, similarly t4 minus t3 are in AP or GP, for such series we have to compute t of n first. So our objective will be t of n. The moment we calculate t of n, we can easily calculate s of n, that is nothing but summation of individual terms and varying from n is equal to 1 to infinity, or you can say n terms. It's given on the question. So let's start with the question. You will get more feel from the question only. Now the question is, find the summation of this series where n terms are given and the first term is 6, second term is 30 and so on. So all you have to do is observe in this kind of question. Just check the difference from the next term and the previous term. I think here difference is 7 here. Now between T3 and T2 the difference will be 9, as you can see here. Now from T4 and T3 the difference will be 11, and similarly for the next term the difference, as you can observe, the difference is moving in AP. The first difference is 7, next is 9, next is 11, and next I can predict it will be 13 here, and so on. So as I can see, the difference is moving in AP here. So in this kind of question, you have to do one thing. You have to write S again. Right now, the problem is I cannot add up all the terms because they are neither in AP nor in GP here. So in order to make them in AP, I'm going to create the difference because the difference is in AP. So I'm going to create the difference here. So in order to create an AP, I'm going to shift one term and write here. So that will be, I'm going to write the same sequence from 6 to n term, but I'm going to here make a space here. That means I'm going to write here 6 plus 13 plus 22 here and so on till the nth term till here. And here I'm going to subtract the series because the difference is coming in AP here. So S minus S will be 0 here, and on the other side you will get this as 6 plus, here you will get this as 7 plus 9 plus, as you can see from the difference will be 11, and as you can see the difference is moving in AP, and till the last term we are doing like this, and here something will come here. Let's say plus t of n minus t of n minus 1 here, something like this will come, and minus t of n here. Now our objective is to calculate the nth term only. This will be the whole objective. Once you get t of n, you will get the answer. Now I'm going to take minus t of n on the other side here. So we'll get this as T of n is equal to, now if you observe one more thing here, the number of terms, I think till here to here number of terms is equal to here, as you can say, n number of terms are here, because starting with this and ending with nth term, I think in total we have n term here. Now this will be equal to, as you can say here, 7 plus 9 plus 11 and so on till the nth term, and t of minus t of n I have taken on the other side here. So I think this is sum of odd natural number is written here. In order to make the complete series, I'm going to add 5 here. Similarly, I'm going to add 3 and I'm going to add 1 here. Now why I'm doing this? Because I know sum of first odd natural number here. I'm going to write t of n on the other side. Now if I added these terms, the number of terms will increase here. And in order to make 6 here, the sum here is, I think the sum here is 9. And we need to subtract something. That means we need to subtract here 3. Because already it was 6. I am splitting 6 in this two parts. That is 1 plus 3 plus 5 and minus 3. So here number of terms will be increased here. So number of terms will be here. I've added 2 extra terms. So it will be n plus 2 terms here. Now the t of n will be equal to, now we know sum of first odd n natural number, that is n square. So for n natural number it is n square. So for n plus 2 natural number it will be n plus 2 whole square and minus 3 here. Now once we get t of n, I can easily compute s of n. Now t of n I can further simplify as n square plus 4n, and you will get plus 4 and minus 1, that is plus 1 here. Now I can calculate s of n as summation of t of n. Here n is varying from 1 to n here. Now this will be equal to summation of n square plus 4 times summation of n, and plus summation of 1 will be n only. So this will be equal to n square, we know summation of n square, that is n into n plus 1 into 2n plus 1 divided by 6 here, plus this will be equal to 4 times n into n plus 1 divided by 2 and then plus n. So this will be our final answer for this question. And now I'll give you one more question on type 2. Now the next question is, find the sum of the series 3 plus 8 plus 15 plus 24 till nth term. So again you have to observe the same thing, the difference between consecutive terms. Here the difference is 5. Next difference is, I think, 7. Next difference is, I think clearly you can see, next difference is 9 here, and so on. If you observe one thing, this difference is increasing in AP. As you can see, 5, 7 and 9. These numbers are in AP because the common difference is 2. And the next common difference will be, you can predict here easily, 11. So in this case, we have to create the difference here. That's why it is called difference, method of difference here. So shift one term and write. So 3 plus 8 plus 15 and so on till minus t of n, sorry, plus t of n here. And I'm going to subtract, because the moment I subtract, I'll get the sequence in AP. So s plus s, s minus s will be 0 here. We'll get this as 3 plus 5 plus 7 plus 9 plus 11 and so on. So on till the nth term and minus t of n here. So t of n I'm going to take on the other side. I'll get this as 5 plus 7 plus 9 and so on till nth term. Now in order to calculate the summation of first and odd natural number, I'm going to add here 1 and this should be 3. So I've added one extra term here. That means I need to subtract 1 here. Now the moment I add one more here, I think the number of terms are increased here. The number of terms will be n plus 1 here, number of terms. Now sum of first and odd natural number is n square. So n plus 1 will be n plus 1 whole square and minus 1. So this I can write this as n square plus 2n here, and plus 1 and minus 1 will cancel out. Now I think I can easily calculate s of n. Now s of n will be equal to summation of t of n. N is varying from 1 to n here. Now this will be equal to summation of n square plus summation of 2 times summation of n I can write here. Now you know summation of n square, that is n into n plus 1 multiplied by 2n plus 1 divided by 6 here, and plus 2 times summation of n is n into n plus 1 divided by 2, and then 2 will cancel out here, and further we can simplify this. So the summation n s of n formula is ready here. So this will be our final answer for this. Let's move to type 3. Now the first thing which I'm going to do here is I'm going to generalize, and I'm going to show you how to identify this kind of sequences, then I'm going to show you that how to solve this very particular question. So in this type of series, in type 3, the normally r factors will be given in denominator. As you can see, some factors are given to you, that is n, n plus 1, n plus 2, n plus 3. So in denominator only the sequence will vary, and r as r factor it will vary. They can give you n plus 4, n plus 5 and several factors also. The difference need not to be 1, the difference can be anything. Okay. And in numerator either you will see a constant or 1 here. So first of all you have to write the nth term. So nth term will be equal to 1 upon, as you can see here, n into n plus 1 into n plus 2 into n plus 3 here. Now, once you get that nth term, you have to split the nth term into difference of two terms. The moment you split into difference of two terms, you will get a nice telescopic series here. So for that, how to split the nth term every time, you remember the logic here, which I usually use and always use for this kind of question. I always use this logic, and this is really important. So you have to create in numerator, you have to create difference of last term minus first term. The moment you create last term minus first term from the denominator, automatically you will get the difference here. So last term is n plus 3 here and the first term is n here in denominator. So remember this logic. This logic is really helpful for this kind of question where r number of products is given in denominator. So what I'm going to do here is I'm going to write nth term as, again, now I'm going to create the difference here. As you can see here, n, n plus 1, n plus 2, n plus 3 as it is here. Now I'm going to create the difference, the last term minus first term. Now again I want 1 in numerator. In order to get 1, the difference is 3. So I'm going to divide by 1 by 3 in order to get 1 again. Now I'm going to separate out these two. So the moment you separate out these two, 1 by 3 is outside. I think in the first term, n plus 3 will cancel out. The remaining is 1 upon n into n plus 1 into n plus 2. And similarly minus n will cancel out in the second term, and the remaining term is n into n plus 1. Sorry, n will cancel out. You will get this as n plus 1 into n plus 2 into n plus 3 here. So we'll get this. Now, the moment you put n is equal to 1 to n, you will see a nice telescopic series is formed. Now I'll show you here. So let's say t of 1 is 1 by 3 times. Now put n is equal to 1 here. You will get this as 1 upon 1 into 2 into 3 here minus 1 upon 2 into 3 into 4 here. Similarly, t2 will be equal to 1 by 3 times of 1 upon 2 into 3 into 4 here minus 1 upon 3 into 4 into 5. Similarly, t3, so that will be 1 by 3 times of 1 upon 3 into 4 into 5 minus 1 upon 4 into 5 into 6, and so on. It will go till t of n. So I'll write the nth term here directly, that is 1 by 3 times of, as I've written here on the left hand side, n into n plus 1 into n plus 2 minus 1 upon n plus 1 into n plus 2 into n plus 3 here. Now, if you observe one thing, this is the most satisfying part. It is a telescopic series because minus 1 upon 2 into 3 into 4 and plus 1 upon 2 into 3 into 4 will cancel out like this. Similarly, minus 1 upon 3 into 4 into 5 will cancel out with this plus part. And similarly, alternate cancellation will happen like this. And only remaining two terms are here. So I'm going to write s of n. Let me erase this part. Now after cancellation, I'll get s of n as the first term is 1 by 3 times of, you will get this as 1 by 1 into 2 into 3 is 1 by 6 here, and minus 1 upon the last term, you will get this as n plus 1 into n plus 2 into n plus 3 here. So s of n will be this, and they can ask you one more thing, that is s of infinity. So the moment you take the limit, n is tending towards infinity, I think as n is tending towards infinity, 1 upon infinity will be 0. So this term will be 0, and s infinity will be equal to 1 by 18 here. So s infinity will be equal to 1 by 18. So these are the two things they can ask you, sum till nth term or s of infinity will be 1 by 18. Now let's move on to one more question of type 3. Now the question is, find the sum of the series, and the first term is 1 upon 1 into 3 into 5 plus second term is 1 upon 3 into 5 into 7. As you can see, three factors are varying and the sum till nth term I want. Now I forgot to tell you one thing in the introduction of type 3, that is this logic is create the in numerator, last term minus first term is only valid when the difference of the consecutive terms are vary in AP only. So remember this, the logic only works when the difference between consecutive terms factors is in AP only. Now, let me know the S of n in the comment section for this question, S of n and similarly S of n infinity. Now I'll move to type 4 here. Now first I'm going to generalize type 4, then I'm going to solve this particular question. Now if you observe, type 3 and type 4 are exactly similar. The difference is in type 3 you will get r factors in denominator, in type 4 you will get r factors in the numerator. And this will be, the logic will be, which I'm going to give you, will be applicable when the difference between the factors is in AP. The difference can be 1, difference can be 2, difference can be 3 here. So the logic which I'm going to here use is, you have to create in numerator the difference. Okay, our objective will be same. First we'll write the nth term and we're going to split the nth term into difference of two terms, and then you will see a beautiful telescopic series. So here we have to create a numerator that is next to last minus last to first. I'm going to show you T of n first. So T of n, the nth term is, you can easily write, that is n into n plus 1 into n plus 2 into n plus 3. Now T of n, you have to write this as n into n plus 1 into n plus 2 into n plus 3. Now as I said here, you have to create next to last. The last term is n plus 3, you have to create next term to this. So next term to this is n plus 4 here, and minus last to first. So the first term is n here, so last to first is n minus 1 here. And now the difference is 5. Again I want 1, so I'm going to multiply by 1 by 5 here in order to get the same T of n. Now I'm going to split T of n. So if you split T of n, you will get 1 by 5. Now first term is n into n plus 1 into n plus 2, n plus 3, and then n plus 4 here. Minus times you will get this as, here you will get this as n minus 1 into n plus 1 into n plus 2 into n plus 3 here. Now the moment you put here n is equal to 1 to n, you will see the alternate cancellation will occur. Now I'll show you in the next slide. Now I'm going to put n is equal to 1. So for n is equal to 1, I'll get T of 1 as 1 by 5 times of, you will get this as 1 into 2 into 3 and so on till 5 minus. Here you'll get this as 0 into 1 into 2 into so on till, here you'll get this as 4. I'll write 3 into 4. Similarly for T2 is equal to 1 by 5. You will get this as 2 into 3 into 4 into 5 into 6 minus, you will get this as 1 to product 1 to 5 and so on till T of n. So T of n is 1 by 5. This term minus this term. So if you see here, a beautiful sequence is you will see a beautiful sequence and then alternate cancellation here. As you can see, the cancellation, alternate cancellations like this, and it's a beautiful telescopic series. And after getting cancellation, we'll get S of n here directly. So S of n will be, I think 1 by 5 is remaining, and remaining is n into n plus 1 into n plus 2 into n plus 3 and n plus 4 last term. And this will be 0, as you can see, because 0 into anything is 0. So this is our S of n. This will be the final answer. Let's move to type 5. Now let's start with type 5, that is the miscellaneous first part. And so far I've covered type 1 to type 4 that are pretty standard type. So in this question it's given as 1 upon 1 plus 1 square plus 1 raised to power 4 plus 2 upon 1 plus 2 square plus 2 raised to power 4, and similarly 3 upon and this. So in this kind of question you have to generalize the nth term. So nth term will be, as you can see, the numerator is, for the first term it's coming 1, for the second term it's coming 2, for the third term it's coming 3. So numerator is n, for the nth term it will be n, and denominator easily we can generalize. As you can see, the first term is 1 here plus, for the second term, or it's coming as 2 square and then 2 raised to power 4. For the third term it's coming as 3 square and 3 raised to power 4. So for the nth term it will be n square plus n raised to power 4 here. Now I think I can factorize this. So T of n, I can write this as In denominator, I can write this as n square plus n plus 1 and then n square minus n plus 1 here. So again, if you multiply, you'll get the same thing. Now, as I told you in the type 3, if the product of two terms are there or r factors are there, we try to create the difference here. So the difference of these two terms is, I think the difference of these two terms is 2n. So I'm going to multiply and divide by 2 in order to create the difference here. Now I can write t of n as, now let's create the difference here. So 1 by 2 times, now 2n I can write this as n square plus n plus 1 and minus, here I can write this as n square minus n plus 1 here. So again, you will get 2n and again when you divide by 2, you will get n. So I'm creating the difference using type 3. And then n square minus n plus 1 here. Now let's write this separately. So from here, t of n will be equal to 1 by 2 times of, you will get this as 1 upon n square minus n plus 1 here and minus 1 upon n square plus n plus 1 here. So our strategy will be same every time. We're going to split nth term into as a difference of two terms so that you will see a beautiful telescopic series here. Now when you put n is equal to 1 here, you will get t of 1. T of 1 will be 1 by 2 times of, you can write this as 1 upon 1 minus 1 upon 3 here. T2 will be 1 by 2 times of, you will get this as, when you put 2 here, you will get this as 4 minus 2, that is 2 and plus 1, 3. Minus 1 upon, if you put 2 here, you will get this as 4 plus 2, 6 and then 7. And so on till t of n. And there is no need to write t of 3 because we'll get to know from t2 only the alternate cancellation. Now I think you see the beautiful series here, alternate cancellation, and this is the most satisfying part. This 2 will cancel out, this 2 will cancel out, and cancellation will happen like this. Now let me erase the other part. Now s of n will be equal to, here 1 by 2 is remaining, first of first is remaining, that is 1 minus 1 upon n square plus n plus 1 is remaining here. Now, if they can ask you one more thing, that is s of infinity, they can ask you. So you're going to take limit on both sides, limit n is tending towards infinity, and you'll get this as 1 by 2, 1 minus, I think this term will be 0 here because 1 upon infinity is 0. So from here, s of infinity will be equal to half. Sum till infinite terms will be half, and sum of n terms is given like this. Let's move on to part 6. Now let's start with type 6. So we have to solve this question. Summation n is varying from 1 to 1999. Root over 1 plus 1 upon n square plus 1 upon n plus 1 whole square. So we'll start with t of n only. Our strategy will remain exactly same. First I'm going to write the nth term. After writing nth term, I'll try to split nth term into as a difference of two terms. So a beautiful telescopic series will come. So let's start with nth term only. So t of n you can easily generalize from here. That is 1 plus 1 upon n square plus 1 upon n plus 1 whole square. Now the idea behind this question is, first we have to split this into two terms. But the problem is, first obstacle is root over is there. So in order to remove the root over, I'm going to make a perfect square inside. I'll try to make a perfect square inside. So we'll get this as root over. I'm going to write this as 1 by n minus 1 upon n plus 1 whole square. So if you square this again, I think you'll get both of the terms again. But you'll get something additionally, that is minus times 2ab. So we have to add plus 2 times 2ab here. And then plus 1 as it is here. Now t of n will be, if you analyze these two terms here for a moment, if you analyze these two terms, 1 by n minus 1 upon n plus 1 is how much? I think it will be equal to 1 upon n into n plus 1 only. So I'm going to write this as 1 upon n into n plus 1. So this will be root over 1 upon n into n plus 1 because their difference is 1 n whole square plus 2 times of 1 by n into 1 upon n plus 1 here and then plus 1. If you observe one thing, it's a perfect square of 1 upon n into n plus 1 because this is a square, this is b square and this is 2ab as you can see. So we got a perfect square here. So t of n I can write this as, it's a perfect square of root over, I can write this as 1 upon n into n plus 1 and then plus 1 whole square here and root over. So T of n will be equal to, I can write this as 1 upon n into n plus 1 and then plus 1. Now the question arises, sir, you told us to split the nth term. Now I'm going to split the nth term. As of now, I didn't split here because first obstacle we have just now covered. We have successfully removed the root over. Now I'm going to write T of n again as 1 upon, see 1 upon n into n plus 1 can be again rewritten as 1 upon n minus 1 upon n plus 1 and then plus 1. So I've successfully created T of n as a difference of two terms here. Now I'm going to form a telescopic series and I'm going to find the sum of the series. Now put n is equal to 1, you will get T of n as 1 minus 1 upon 2 plus 1 here. Now T2 will be equal to here 1 by 2 minus 1 upon 3 and then plus 1. Similarly T3 will be equal to 1 by 3 minus 1 by 4 and plus 1 and so on. The last term which is I have to calculate is T199, which will be equal to 1 upon 1999 minus 1 upon 2000 plus 1. Now if you add all the terms here, you will see a nice telescopic series, and this is the most satisfying part. Minus 1 by 2 plus 1 by 2 will cancel out, and similarly cancellation will happen like this. So the moment you calculate the sum, you will get this S of n will be equal to the total sum of nth term will be equal to 1 is remaining here and minus 1 by 2000 is remaining, and then 1111 if you add 1990 times, you will get this as 1999. Then here S of n will be equal to, or S of you can say 1999 terms will be equal to 2000 minus 1 by 2000 will be our final answer. Let's move to type 7. Now moving on to type 7, S of n is given as 1 by 4 plus 1 into 3 upon 4 into 6 plus 1 into 3 into 5 upon 4 into 6 into 8 and so on till nth terms. Now you have to write the nth term. You can generalize easily because numerator odd terms are there and denominator even terms are there. So easily you can generalize. Now after writing nth term, you have to do something so that it comes as difference of two terms like this. And after writing the difference of two terms, a nice and beautiful telescopic series should form. So let me know the answer in the comment box how to create a telescopic series with T of n. So I'm going to end the lecture here and that will be all.